Hi everybody, Martin here, and this week I have a lot of nice progress to show you on the Marble Machine X rebuild. I have been doing 12-hour building days for the whole week, and I'm really excited to show you all the progress I've made. In part 1 of this video, I will continue the brutal disassembly of the Marble Machine X that I began last week. In part 2, I will show you the assembling of new parts onto the Marble Machine X. And in the third part, I will try to answer the question on why I am doing this redesign. I don't think I managed to provide enough context for this decision to make the redesign, and I hope to fix some context for you in part 3. I started disassembling these marble dropping arms, and the brutal part with this is that I think it's the third time I'm making and disassembling all the 38 arms of the Marble Machine X. This plywood piece will be used again. Here's 2 links for the symbol. They will be used again, and the rest will be sculptures. Next, I'm disassembling all the marble gates on the entire Marble Machine X. Again, I've done this before, but the even more brutal part with these marble gates is that I said when I was building them that if these gates are not working, I will give up and quit on the Marble Machine X. Maybe I actually should give up. Maybe this is sunken cost fallacy, meaning I'm too invested in the machine to see the truth that I should actually give up, or I'm just devoted to finishing my upcoming masterpiece. Only time will tell. I'm going to save this piece. This is what I'm gonna build the next design on. The rest goes in the box. I am about to slaughter this machine using the angle grinder, and the sparks will fly everywhere in my music studio. I had this idea, maybe if I take a box, fill it with magnets, the magnets will capture all the sparks. Do you think this will work? Let's find out. The magnetic spark box was mostly for fun. It captured kind of half the sparks. I think the kinetic energy makes a lot of them bounce straight out, and also the Curie temperature is the degrees in which a material loses its magnetic properties. So if the sparks are warmer than that, they won't stick to the magnet. So it was just for fun, kind of stupid. Basically everything in the studio got covered in metal sparks in the end, so yeah. The metal bar I'm removing here is actually a leftover from a previous system. When I changed my mind around that design, the bar itself wasn't in the way for anything, so I just left it on there as a kind of structural stability. But the bar is now in the way for my new design, so I'm going to remove it. Here I'm taking away the remaining marble gates for the drums and for the bass. I'm basically angle grinding away years of my life right here, and it's kind of crazy, but the Marble Machine X has surprised me several times with its demand for stability in the mechanical functions, and this is what I'm going deeper into in part 3 of this video. So I was really absolutely sure that these marble gates were cutting it perfectly, and as we will see later in the video, there's a reason for why they don't. So these tracks and the bottom plate will be reused in my new design. Everything else will go away. This will be saved for a later episode. I'm actually surprised. I'm having a quite emotional reaction to seeing all these pieces away from the machine. It's like watching your life pass by you. It's like sad and super cool at the same time, because if I move the camera to the Marble Machine X standing over there, I now know that everything on this machine, everything you see on this machine is working. It doesn't have any flawed parts at the moment because I removed all the flawed parts. Okay, out with the old, in with the new. We're ready for part 2, all the new parts, including the Marble Divider 3.0. Before working on the marble divider, I have to finish up what I started last week, the new spring tension system. So here are the custom M5 rods from Henk Rijkaard Kotterij.be. I'm mounting the adjustment M5 rods to the bar that I welded last week. So it's a real luxury to have laser cut parts, but they always need some post-processing, and that's what I'm going to do now. I need to countersink these, but I have to make sure that I countersink them on the correct side, because it's not the same. Designing in 2D and ordering laser cut parts is a method that I've been using so much in the Marble Machine X process. It's a really convenient way to get very precise parts, but the post-processing of these parts is always very laborious. It's almost half a day of intense work before I can start assembling the profiles onto the Marble Machine X. Seeing how they all line up with each other here makes me very, very happy. It's exactly what I wanted them to do. I'm really proud of the cutting work I've done here. Everything lines up perfectly, everything worked out the way I thought it would. And this is a little bit the difference between me now and me 2 years ago when I did all the work I'm removing in this redesign, is that I have a better understanding of how things in CAD turns out when you assemble them in real life. And the transition on this sub-assembly from CAD to real life, totally smooth. So, feather in my hat for this. I removed this part in the last video. This is the old version. This could get stuck like this, the marbles could get stuck here underneath. It was complicated. And most of all, it's not needed anymore. And it was loud here because the stop here was super loud. So this is the new version. I put one of this together just so we can try out the part that it's going to slide on. I think I've done a great job with this design. Look the simple way I'm getting this stop correct here. This has to be able to move like this. And the spacer offset looks correct. By removing this possible failing point, we make the machine much more reliable. I'm a little bit insecure to see how thick this felt will be when this part is tensioned. So I have to make my best guess. So what I need to do is that I need to decide on the space between this aluminum part here and the back side of this plywood wall here, the blue plane, because that's where the felt is gonna go. And right now I think it's about 5mm, 4.5. I think I wanna increase the space between these two parts because it's easier to shim later, to add material accurately than it is to remove material. To be able to assemble this without taking the two metal frames apart, I have to have some slack here. I'm not gonna bore you with this, but I want to give you two super quick examples of the finer aspects of toolpath programming. When this center piece of wood here comes loose, it can go to the side and cause problems for the cutting bit. I'm going to make sure that the machine removes this part of the wood before cutting the contour. So now I'm choosing to cut out that little rectangle. So then the bit comes in and cuts out the center of that pocket, and if we fast forward, the bit will come back and cut out the edge. And as you can see now, there's no wood that can come loose and disturb the tool. The second thing I want to show you is this parallel toolpath over here. So this toolpath is now cutting on this side, all these strange holes. What I actually wanted to do is to cut these pockets that it's cutting right now. So if I open the preferences for this toolpath, I just put tool center on boundary and I make an additional offset of -1mm. I hit OK. Voila! Now the toolpath is only cutting the pockets I want the toolpath to cut. Early bird catches the worm. A while back I built this new plywood storage. It's so great. Let me show you. Tubing on the wall, plywood down here. So great. When I cut on the CNC machine, I try to lay out the pieces so the frame remains. The scrap wood frames becomes an art piece like this. Plywood wants to be stored flat, otherwise it becomes a banana. And today we're gonna use this one. In this bottle there's something I wanted to try for 3 years since I was in the Spelklock Museum and the technicians there told me about graphite powder. So it's a dry lubricant, and if I open the marble divider here you can see these internal tracks. One of the things that I'm chasing in this redesign is friction. I want to reduce friction in mechanical movements. So I'm going to try to apply... Oh, wow, that was too much. That is way too much. Anyway, this should reduce friction in this movement. So let's compare to one. Oh, definitely. Wow! If you take a normal pencil and you scrape some powder off the tip, you basically have graphite powder. And I never forget when my first guitar teacher took a pencil and scraped some graphite powder into the saddle of an electric guitar to make the strings slide better when being tuned over the saddle. I thought it was so cool. And then when the technicians at Spelklock Museum told me about this dry lubricant, I wanted to try it ever since, and now I found the perfect application. Before, that clap is disappearing with the felt. I did some glue tests here on the felt to the plywood. Oh, wow. Okay. Easy winner, wood glue. Shout out to my friend Olivier from ID Acoustic, who just randomly left this felt and said maybe it can be useful for something. It's acoustic felt and it came in perfect. I think it really looks like a music instrument when you add felt. It has that kind of piano vibe to it. And I was also really happy to see that it just snaps into place in the frame of the Marble Machine X. Again, I'm happy to see that doing this transition from CAD to real life is something that comes easier and more natural for me the more I do it. I want to transfer the perfect center of these holes onto the plywood behind. So I'm drilling in with the same countersink that made this countersunk. That way I will get a divot. Now when I drill this hole, the tip of the drill will find the perfect center. So the marble divider is in place and I can start working on making 38 of these pieces, and here is the parts for that. And I thought this assembly would take some time, but I hugely underestimated how much work it was to put all these parts together. So for fun, I'm gonna add an operation count where I'm gonna count up all the operations that I had to do. So it starts with punching these 2 holes and drilling them out on the drill press. Deburring 6 holes with the countersink. Then I'm using this jig to tap 3 M4 threads, and this jig helps me do 90-degree taps. In this soft aluminium, the tap is not following the hole so well, so when I just hold the screw gun freehand, the threads doesn't come out as straight and nice as they do here. Next, I'm sanding the 2 broadsides with 3 grades of sandpaper, and then I'm doing the same for the narrow sides. Laser cutting leaves these perpendicular lines, and I need to get them out to make this aluminium part slide nicely inside the wood structure. That was the last one. This step alone, making sure that the edges are smooth, took like 3.5 hours. I'm drilling out these 2 holes on these spacer links. I'm making sure to dip the drill in water between each operation, otherwise the drill will get hot and blunt very soon. This is stainless steel. Then I'm sanding the steel clean because I want a good Loctite bond later on. I'm peeling the protection plastic off of these long stainless links. sanding the long links and drilling out the 3 holes, and again dipping the drill in water between each drill operation. Then I'm countersinking 2 holes and flatten 2 holes out on the backside after the countersink, and cleaning it up again with a wire brush on 2 sides. So now everything is ready for the Loctite bond. I'm adding Loctite between each of these metal layers. I have the link going on, that's the spacer link, and then I have the long link. So I have to put in 2 screws into the threads and then tighten it all together. Then I have to clean the Loctite up, and this looks actually great. So later on, I found out a little more efficient way. I'm adding Loctite to all the parts in one go, and then I can just assemble it. And that way I could speed up this whole process. Before the Loctite sets, I'm checking with another piece that the link is sitting perfectly straight. When it's a little bit off, I can just manipulate how it sits, check again, and now you can see the hole is lining up perfectly to the right there. Perfect. And here is my collection of little bunnies kissing each other. Do you also see the bunnies? All of a sudden I just saw the bunnies. Next step, I'm adding this screw, and then I'm adding this nut on the back side. Then I put some Loctite before tightening everything up. Cutting the 3 screws shorter and then sanding them down to the surface. So now I need to extract this plywood part, and these Boston screws or Chicago screws, whatever it is, has been Loctited internally. So I had to clamp it really hard into the vise to be able to break this Loctite bond. But in the end I learned how to do it, and now I can extract the plywood part, and it resulted in this beautiful flower. So now I was ready to put the metal part together with the plywood parts, and this is kind of when this part really comes to life. So the fit was looser than what I needed, kind of a lot of play, which made this left and right movement possible. So I found these shim washers. So I'm adding shim washers wherever they're needed. Then I'm adding the 2 sides of the Boston screw, adding some Loctite internal to the Boston screw, and tightening everything up. Apologies to Chicago if it's called Chicago screw. The shim washers did a great job at removing the sideways play while maintaining the rotation movement that we want. Next step was to countersink the end and then sand all the residue from the Loctite. And then I have these spacers that I need to cut in half. So I figured out that I could put them on a stick like this and sand them on the disc sander to half of the size. And now I'm ready to mount all these parts onto the Marble Machine X. This was itself a kind of super annoying job, because the bond between the link where I'm going into the machine there is an afterthought because of this new design. That's where I'm using these brass spacers to make everything fit. In the end, I found out a really great way of mounting all this, but it's like 6 parts per thing and very, very fiddly. And I'm standing on the top of a ladder. That was crazy difficult. That was 7 hours of assembly. This connection down here is very time consuming. I've been standing on this ladder the whole day to get these parts on the machine. It's almost perfect. I have some tweaks to do. Still, looks very good. So here you can see that these holes are lining up with the spaces here between the links. That's because we're gonna have PMA pipes between these links. And this is fantastic, bypassing the marbles between these links. Before, the marbles were interacting with the links, which is a whole problematic area that we have completely obliterated. I just finished this before the release of the video. There are some channels that are interacting with each other. It's just some bolts that I need to trim off, and I will do that in the next episode. So let's check in on our operation count. 76 individual operation, and I'm adding 76 for getting the part into place and 76 for getting the part out of place, which means 228 operation. That doesn't sound so bad, right? Oh yeah, I need to multiply that by 38 because I created 38 of these sub-assemblies. So I did 8,664 manual operations to assemble these 38 parts. This is why post-processing of laser cut parts takes some real amount of time. This means that we have done a great start of the autumn push for the marble machine redesign. I'm super happy with this. I want to explain to you why I am doing this major rebuild of the Marble Machine X. I haven't really managed to explain this well, but I think I have an example now that will show you why I think this rebuild is highly motivated. So let's get straight into it. The main issue with the previous design is that the marbles could get stuck inside the different marble gates. So if we do a little back of the napkin math, we can kind of look at the probability for a marble to get stuck. And a marble getting stuck is a critical failure, so we cannot allow it. So if I was going to tell you that the Marble Machine X previous design was 99% good, how does that sound to you? Pretty good, right? Okay, let's look at it, because the machine is designed to have 8 marbles per crank turn. There are 64 crank turns per programming wheel revolution. 8 times 64 equals 512 marbles. The Marble Machine original song has 7 complete revolutions of the programming wheel, 512 times 7, and we have 3,584 marbles to play the original song. So 99% stability of the marble handling means that 1 out of 100 marbles will fail. That during the original Marble Machine song, 36 marbles are going to fail. So let's increase the performance, which I kept doing with the previous design. So I kept tweaking it and I made the stability up to 99.9%. That sounds really great, right? Well, that means that 1 out of 1,000 marbles will fail. And as you saw, it took like 3,500 marbles to play a song. So 3.5 marbles will fail per song. This machine is clearly not working when it has 99.9% performance. Let's increase it 1 decimal more. I'm tweaking the machine to 99.99 stability in the marble drops. Only 1 of 10,000 marbles will fail. That means that we still have a 40% chance that the machine will fail during 1 song. And if I play a concert with 10 songs, 3 marbles will fail. And if you think of me in the studio trying to film a song, or I'm easily playing the same song 10 times over, this means that day the Marble Machine X will break. Hence, my friends, if the stability is at 99.99%, the Marble Machine X can only play 1 song before it completely breaks down. And as theoretical as all this is, I think this correlates to my real-world experience really, really well. This is not good enough at all. I think this 99.99 stability state of the previous design of the Marble Machine X can be described as a local maximum. This is a fancy term that I don't know if I'm using correctly. I learned it because Tesla is just releasing a new beta of a full rewrite of their autopilot system. Elon Musk described that the previous code had reached a local maximum. They could iterate on it, but they couldn't get it further. And I think that's exactly what happened with the Marble Machine X. I reached this bump, the local maximum, and I know there is a higher global maximum that I have to go to make this machine functional. And you can try to keep on tweaking a system, but if it's already reached its local maximum, you kind of have to take another route that has a better possibility of reaching the global maximum. Let's try to define the global maximum, the goal that we're working on with this redesign. So let's say I want to play 1,000 songs without a critical failure. That means 3.5 million marbles. So let's just add decimals to the percentage number to see how many nines we need to get to that number. With 99.999, 1 out of 100,000 marbles would fail. 99.9999, 1 in a million, and 99 with 5 nines, 1 in 10 million marbles would statistically fail. So to answer your potential question on why I'm doing this rebuild, it is to get the Marble Machine X from the local maximum of 99.99%, where I was before, to my new target of 99.99999% of potential marble drop failure. Oh, but wait, I just saw something. If this isn't proof that I'm stuck at the local maximum, I don't know what is. This, my friends, is how math works, okay? This is a solid mathematical napkin proof, if I ever saw one, that the Marble Machine X have been stuck at a local maximum. If this isn't answering your question on why I'm doing the redesign, I don't know what will. I'm sorry to be that person who always tries to relate every single conversation to something related to Tesla. I'm sure you have a couple of friends like that. I know all my friends have at least one friend like that. But I think this analogy is really good. So yesterday Elon wrote, with full self-driving we got stuck in a lot of local maximums, which wasn't clear until we hit the ceiling. This time, with the rewrite, he means it's right. And then someone says, just to be clear, when he says it's right, what Elon Musk really means is it's a lot less wrong. And then Elon responds to that, at least success is in the set of all possible outcomes this time. And this is exactly why I'm doing the redesign of the Marble Machine X. At least success is in the set of all possible outcomes this time. I have no clue if this will work, but I know for sure that the previous system would never worked, okay? That is why I'm ripping out 2 years of my life from this machine at the moment, to make success one of all the possible outcomes. This is the only way forward for the Marble Machine X. So now I hope you have some context on why I think this redesign is highly motivated, and potentially also a grasp of like the mechanical problem I'm up against. The large number of mechanical repetitions on the Marble Machine X just makes this into the super difficult task and machine that this is. It's like I have underestimated this during the whole process of the machine. I think it's kind of interesting reality check that 99.99% is really rubbish. I think that is saying something about the problem of the Marble Machine X.